Hello, my name is Steve Carlson. I am a master's student at the Robotic Workers Lab at the University of Nevada, Reno. Presented here is the MiniHawk-VTOL, an open-access VTOL micro-air vehicle platform, optimized for long-term operation through the concept of migratory aerial robotic behavior. Its design is additionally aimed to enable low overhead swarming research by following a rapid prototyping fabrication process using standard FDM 3D printing, making it reproducible by any decent-sized 3D printer. An aforementioned notional motion profile is illustrated in this flow diagram. Here, the vehicle recharges using a solar cell array embedded in its wings, until sufficient energy is stored to launch the next mission part. The vehicle lands relying on onboard perception and hibernates until it has recharged and is ready to proceed to the next mission cycle. To enable the tasks of autonomous safe landing site discovery and near-ground obstacle avoidance, it will be outfitted with a stereo camera pair and an onboard high-level computer. Energy charging and hibernation will be enabled by a custom-developed maximum power point tracker and battery management system. The fundamental goal of this project is to provide long-term autonomy in the field of aerial robotics by removing the common restrictions related to vehicle energy state, i.e. the need to return to home before running out of battery, and the required human intervention to swap batteries. Combining autonomous perception with safe landing, recharge, and VTOL takeoff capabilities, we may demonstrate bringing swarms of flying robots out of the lab and letting them run multi-day mission profiles out in the field with minimum human intervention, an unprecedented scale of field robotic deployment. A new class of long-term autonomy research paths are considered based on the presented platform. One path, intrinsic to the aerial robot, is the concept of adding a minimal design mechanism to enable limited ground locomotion capabilities, and/or perching to optimize solar recharging orientation of the panels. Extrinsic opportunities include deploying this as part of a heterogeneous robot group where, operating alongside ground-based systems, it is deployed and retrieved autonomously. The center-right image shows a notional grasping point mounted to the MiniHawk with a detection marker for a ground-based mobile manipulation robot to holster and deploy the MiniHawk-VTOL. The MiniHawk can also be used in a homogeneous robotic swarm for multi-robot mission execution. This will require research to coordinate takeoff and landings and synchronize landing site selections amongst group knowledge. Finally, we are considering multi-robot reconfigurability by adding the capacity to physically attach distinct MiniHawk-VTOL units at the wingtips to create an array that may result in improved aerodynamic efficiency and flight times.